Alright, back again. And now we can go ahead and we can start building. Try to get this semi-correct. Okay. Don't let this trip you up. A lot of people seem to have problems with this convention on how to build um, the LFS system. Right now what we're doing is we're building a tool chain. What we need first is, the reason why we installed a host OS, because we need system programs and everything else like that to build our LFS system. So we're going to use Ubuntu as our host, and we're going to use the tools, the resources that Ubuntu has, and the ones that we beefed up to install our new LFS system alongside of Ubuntu. After our Ubuntu is installed, or after our LFS is installed, then we can delete the host OS, in this case is Ubuntu, and we can then just have a regular LFS. Now, previously in the past, there was LFS Live CD, but before that there was not an LFS Live CD. So LFS kind of natively acts like a, I want to say like a parasite, which is a bad word, but sort of like a parasitic operating system. It's biological terms to stuff. It's just, blah, it sounds nasty. But that's essentially what's happening here. Now, the first thing we had to do is, in the first section, we have to actually install a toolchain that we will use then to chroot and jump into our LFS partition and build our LFS machine from there. Okay. So, first, we have to go and install binutils. Convention is to tar extract the package, in this case bin tab. Okay, we have the extractor package. We need to cd into our extracted package, and then we need to make a build directory for this anyway. Back out. There's only a few of those we need to make a build directory for. They're specified in the book, and that's what we'll be doing there. Now you'll see here this is pass 1. I think there's actually about two or four passes for binutils, and it may look a little monotonous at first if you're just installing and not really knowing what's going on, but we're building a little bit of functionality on pass 1. On pass 2 we'll build more functionality to it, and then on pass 3 we'll build more, and if there is a pass 4 then we'll actually build the rest of it. But it's like a layering process, and that's that. Sort of like painting a wall. If we were to install the whole system at one time, it's going to check for things that aren't installed, because we do not have them installed on our LFS machine. So we need to build up small bits, and we need to make build up a little bit more of the other things that it expects to be there, and then after it expects those things to be there, then we'll go back and we'll build the rest of it. And it's like I said, it's like a layering process. Okay, sort of like if you're painting a wall, you would have first you put on the primer coat, let it dry, then you put on the first coat, and then you put on the second coat, blah blah blah. So let's cd into binutils, our extracted package. Okay, and then from here we're going to make a directory for both, but inside of binutils we're going to make the directory back up and out. We're going to call that binutils build. Okay, now we're going to cd back up into the binutils build directory. Okay, so we're here. Now it says here the binutils documentation recommends building binutils outside the source directory in a dedicated build directory. Okay, and if you try to build inside the build directory, I have noticed that it won't let you, and I'm glad it kind of doesn't do that. So from within here we're going to say binutils 2.24 configure. prefix equals tools with sysroot equals $LFS with lib path is going to equal tools lib target is going to equal $LFS underscore target. We're going to say disable NOS, and also we're going to say disable W error. Check that. Brief glance. Everything looks fine. Let that configure run for a second. And now we can go ahead and let's say make. Okay, that's going to go ahead and make. And while it's making, we're going to look at some of the stuff here we skipped over. SBU times. Read about SBUs, but the SBU times, basically, when you look at something like bin utils, since it has an approximate build time of 1 SBU, okay, and what you do is you can time from when you configure, when the configure, I think it's when the configure is done, okay, actually, let's go read it. Approximation, blah blah blah, the lower systems, the XP works as follows. First package to be compiled, time it takes to compile this package is what will be referred to as standard build unit. Okay. When does it actually happen? I think it happens after the configure, during the make. I could be totally wrong. But say, if it takes me 5 minutes to 1 SBU, okay, then I'll know that when something like GCC Pass 1 comes along, and it takes 5.5 SBUs, I can calculate how long this should take me. So with 5.5, it should be something like 27, 28 minutes, okay? But this is totally for me, for my computer, and 2 gigs of RAM. Now if you have a different machine, 4 gigs of RAM, that's going to take you probably 14 minutes. If you have 8 gigs of RAM, that's probably going to take you 7 minutes to do this many SBUs. So the SBU time is totally up to you. And you can calculate that by how long it takes to, I think it's after the make, but you have to read that. After you run configure, then make install, or whatever. But you can calculate that. Now, it's a good idea to approximate how long something should be. Because if we're talking about, we're running something that's, say, 2 SBUs, and you know your SBU time is about 5 minutes in SBU, so you're going to have 10 minutes of total time. But if that package takes 2 hours, then you have a serious problem. Okay. And 2, there's some SBU times in here that are very big. 4.7 is not really that big, but there's one. There's one down here, glibc maybe. glibc at 17. GCC. This is 55 SBUs, okay? So if you're running this and you say, alright, I got 5 minutes per SBU, 55, that's got to be about 3-4 hours, okay? And it's over in 20 minutes, then you may have a problem. Okay, and you probably know you have a problem because you'll see all kind of errors and stuff like that going on, right? But even if you see that, say, okay, this is going to take you 4 hours, like you had to take a nap, eat lunch, go walk the dog, or go surfing, something. Okay, so it's always a good idea to approximate and keep an eye on what's going on. Now, test suites, we'll talk about them when they come up. use, and make ops. It says here, in previous LFS installs, they've been against make ops because they can cause errors. If you have a dual core, triple, quad core, in previous LFS installs, they shooed you against optimizing cores at this stage, even at the building stage. Okay, now for this here, compilation time can be parallel make program for instance. Okay, for this here, it doesn't look like they're really too concerned about it with this install. So if you do have more than one core, you can look into that. But I have a single core, and it's a Celeron, so I'm not really going to do any make flags or JOps or anything else like that. And I would kind of guard against optimizing for more cores. And in previous LFS installs, they've really tried to get you away from that. Only because certain things get built at certain times, and when it's optimized, even for dual cores or quad cores, there's been some errors been reported about that, and it'd be a bad idea to really catch an error at such an early stage. Okay, SBUs, introduction, toolchain, blah blah. Alright, like I said, in this chapter here, in 5 point wherever we're at, we're just going to be building a toolchain. Okay, now if you take a brief glance at all these packages here we have to install, this is only it's a temporary toolchain, but it's necessary. It's going to provide all the tools that we need, all our test programs that we need to test the actual basic software that we're going to be installing in the next chapter, which is chapter 6. And this is where we'll actually have to chroot into the system, create directories, and create a lot of our symlinks and everything else like that. And this is where it really takes off. Okay, so right now we're only building the toolchain. We're on binutils pass 1. We just ran our make. Okay, and should have had no errors here. Okay, clear. Make is done. And it says here, if building on an x86 64-bit, create a symlink to ensure the sanity of the toolchain. If you're not building on a 64, you don't really have to do this. Okay, but I would read up on that. If you are building on a for x86 only, I'd read up on this part here. I'm pretty sure you do not have to do this. In case you name M in x86_64 make directory for both tools, lib, and link symbolic lib tools lib 64 and close the case statement with case backwards. Good. And make install. Okay. Should take no time at all. Okay, so binutils pass 1 is done, and section 5.5 will do GCC. So it's all done. Now what we can do is we need to jump back up to the sources directory. We need to remove the binutils extracted package, which is 2.24, and the binutils build directory. Okay, and that's it. Do not remove your tarball because it's only pass 1. We're going to need that. Matter of fact, I don't even like removing tarballs until I have the system up and running, and then maybe if I might remove all the tar balls. But keep your tar balls. You can remove your extracted package and your build directory if you have one. And simple as that. Okay, it's a good deal. Tar XVF GCC 482.targz2. Alright, so with that, I'm going to cut the video. I'll catch you in the next one.